All right, for this lesson, we need again to know our tangent ratio and also have our calculator handy to be able to apply what's now new to us, the sine and the cosine ratio. So we're going to use that sine and cosine, and we're going to use that for angle measures in special right triangles, and then we're going to solve problems. So the first thing we need to do is just review the tangent ratio from last class. So if I'm going to find x, here is our angle, 28 degrees. We know the hypotenuse is always opposite the 90. 13 is opposite, and x is adjacent. So we know that it's tangent. So the tangent of 28 equals opposite over adjacent. So we know from experience then that when we do this multiplication of the denominator, we're going to end up dividing by the tangent. So again, if you want to, once you write it down, you could go right to this, but you have to understand the algebra behind it. So 13 divided by tangent 28 is about 5.6, I believe, 5.64. Okay. Again, this is the hypotenuse because it's opposite the 90. X is opposite now, and 22 is adjacent. So we're going to go the tangent of 39 equals opposite over adjacent. And this is one where we would just multiply by 22 and be done. So 22 tangent 39 gives us about 17.82. And then finally, again, the hypotenuse is unknown. 4 is opposite, and x is adjacent. So the tangent of 46 degrees is 4 over x. Now remember, it's going to be a division then because we have x in the denominator. So I don't mind if you skip right to writing that statement. And x is approximately 4.14. Okay, now that's the tangent ratio. Now we're going to use what's called the sine and the cosine, and these involve the legs and the hypotenuse. So one leg and the hypotenuse now. The tangent was both legs. So the sine and cosine are based on opposite and hypotenuse. So, well, that's what the sine is, sorry. The sine is opposite over hypotenuse. The cosine is the adjacent over the hypotenuse. So we've been writing opposite and adjacent and hypotenuse for that reason. They all have a name. So if I use angle A, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse of A. Now if we use B, it's just the opposite. The adjacent would become the opposite, and the opposite would become the adjacent. So now we're going to use those facts to find the sine and the cosine ratios of all of the two acute angles. So the first thing we need to do is we're supposed to find the sine of S and the sine of R, the cosine of S and the cosine of R. Well, let's do one at a time here. Let's use S first. So if we use S, this is always the hypotenuse, and we use angle S, then 63 is opposite and 16 is adjacent. So we know that sine is opposite over hypotenuse. So the sine of S is going to be 63 over 65. The cosine of S, remember cosine, is adjacent over hypotenuse. Well, the cosine of S is adjacent over hypotenuse, 16 over 65. Now we have to shift gears now and talk about R. Well, if we talk about R now, 16 is opposite and 63 is adjacent. So the sine of R, again, opposite over hypotenuse, 16 over 65. And the cosine of R is 63 over 65. And you can see that these are related, obviously. The sine of one is equal to the cosine of the other and vice versa. And that's always going to be the case. Remember, we never look at the right angle either for sine, cosine, and tangent. We only look at the acute angles. Now, that should lead us to this next statement, which makes perfect sense. The sine and cosine of complementary angles means the sine, let's say, of 50 equals the cosine of 40. And the cosine of 50 equals the sine of 40. Now, I just pulled those out of thin air. But notice they have to add up to 90. So if I said the sine of 1 degree would equal the cosine of what? If you said 89, you'd have been correct. The cosine of 55 would equal the cosine of, or the sine of, 35, because 55 plus 35 is 90. And that's all summarized in these statements, okay? But it's basically whatever the angle is, take 90 minus that angle, and it's the other complementary cofunction. These are called cofunctions. They don't use that word here. But sine and cosine are called cofunctions. Now, it says rewriting trigonometric expressions, example 2. Write sine 56 in terms of cosine. Well, the first thing we're going to do is just acknowledge that that's just going to be 90 minus 56. So the cosine of 34 is the same as the sine of 56, as long as they add up to 90. Cosine of 48 in terms of sine. Okay. Well, what would that equal? The sine of 90 minus 48, which I believe is 42. So the cosine of 48 equals the sine of 42. Kind of cool, isn't it? Those are called cofunctions. Okay, now let's actually use them. Again, we're going to use sine and cosine. Now remember, sine is opposite over hypotenuse, and the cosine of an angle is adjacent over hypotenuse. What did I put a J? Hypotenuse. Okay? O and H, A and H. So this is O over H, this is A over H. Okay? So we're going to find X and Y. Now, it's up to you. This angle's 26. This angle then would be, if you said 64, you'd be correct. 90 minus 26. So we can use any amount, anything we want here to find X and Y. I'm going to use 26 because it's the one that's given to us. I'm going to find X first. So if I use the angle 26, this is opposite, this is adjacent, and this is hypotenuse. So if I use opposite, I got to use hypotenuse, and OH is sine. So the sine of 26 equals opposite over hypotenuse. And that's nice, because then we just multiply both sides by 14, and we're done. And by the way, this is going to be an approximation. Try that again. So 14 sine 26 gives us 6.14. Okay? Now, if we stay with the theme and use 26 degrees, it's going to be cosine because it's adjacent over hypotenuse. So y over 14, we're going to multiply by 14, and it's going to be 14 cosine 26, which again, then y is going to give us around 12.58. So the legs are 6.14 and 12.58. And if you thought of this at all in terms of what we did at the beginning, Once you have one side, one leg, you can find the other one by using the Pythagorean theorem. But we're going to use trig here to do this. So let's see if we can find the following. Sine of D, sine of F, cosine of D, and cosine of F. So let's first take F. Okay, let's take F. The hypotenuse is the same, it's 25. So if we take F, 24 would be opposite and 7 would be adjacent. We know that sine is opposite over adjacent, so 24 over 25. And we know that cosine is adjacent over hypotenuse. Now we're going to erase my F and my O and A. We're going to change gears, and we're going to use angle D. So that's opposite and that's adjacent. So now what's the sine of D? Well, that would be 7 over 25. And the cosine of D would be 24 over 25. Which again, they're cofunctions, so that makes perfect sense. The sine of F should equal the cosine of D, and the cosine of F should equal the sine of D. Okay, now we're supposed to, on number 2, write the cosine of 23 degrees in terms of sine. Well, remember, we can take, we're supposed to write the sine, sorry. So this is going to be the sine of 90 minus 23, which is what, 67 degrees, I believe. 90 minus 23. And now we're supposed to find u and t. Well, I'm going to use the 65. Okay, 8 is the hypotenuse. Let's see, t is opposite, u is adjacent. So the first thing we're going to do, I'm going to find t, which is O and H. So the sine of what angle? 65 equals opposite over hypotenuse. So we're going to multiply by 8. So 8 sine 65 is about 7.25. And then we're going to find u by using the cosine because it's adjacent in the hypotenuse. So the cosine of 65 is u over 8. So multiply by 8. So now we're 8 cosine 65. And that u is approximately 3.38. Okay, now we can also apply this very easily, this skill now with trig, to real world problems because trig is very practical. Okay, so you're skiing on a mountain with an altitude of 1,200 feet. There's a picture here below that shows that. The angle of depression, and that means downhill, like so, is 21 degrees. Find the distance x you ski down the mountain to the nearest foot. Okay, so if we take the following sides that we know, and we take the side 21 degrees, then 1,200 would be the opposite, and x would be the hypotenuse. So now we have to think about this. Is it sine or cosine? Well, it's going to be sine because it's opposite over hypotenuse. And I used h instead of x, sorry, so we'll use x. And since it's a division, remember it's going to be 1,200 divided by the sine of 21. And our distance down the hill, or mountain, would be about 48.5 feet. So a little over half a mile. So that's one way, again, to use trig. Now, what if it's 28 degrees instead of 21? Well, we do the exact same thing. We would just change it to 1,200 divided by the sine of 28. And that would give us only 2,500 feet down the hill. So that is how we apply sine and cosine in the real world, or that's one example anyway.